Okay, let's talk about something probably everyone dealing with data bumps into.
Yeah.
It's frustrating. Duplicate entries.
Oh, yeah.
Think about it. How many John Smiths does an organization actually have across, all their different systems? Sales, support.
Marketing, finance, everywhere.
Exactly.
Yeah.
And how do you even know if the John Smith in sales is the same person as the John Smith, spelled Jon,
Right.
in the support database?
Right. Or even J. Smith.
It creates such a headache, doesn't it, for customer service, for trying to personalize anything.
Yeah.
It just breaks down.
It really does. You can't get that single view.
So that's what we're diving into today. There's this really interesting approach, hybrid entity matching in Snowflake, using Soundex and vector embeddings. It sounds technical, but the idea is pretty powerful. It's about taking some established methods and blending them with cutting-edge AI to finally sort out this mess.
That's exactly the mission here. We want to unpack how this kind of hybrid AI solution running right there inside Snowflake helps you figure out who's who.
Inside Snowflake, that's key.
Absolutely, for governance, performance, scalability, all those good things. And it aims for an accuracy that honestly matches the complexity you see in real-world data. It's not just about simple misspellings anymore.
Like that quote you shared from Emily Chan.
Yeah, Emily Chan, she's a product owner working with customer data platforms. She said, our team used to struggle with duplicate customers spread across platforms. With Snowflake's hybrid approach, Soundex plus semantic vectors, we're resolving identities with accuracy that finally matches real-world complexity.
That really sums it up. Okay, so let's break down that challenge a bit more. Why is it so hard? It's not just about spelling, like John Smith versus John Smith.
No, not at all. I mean, that's part of it, the phonetic similarity. But think about the descriptions people might have attached to them.
Right. Like in one system, it says someone like outdoor running shoes.
Exactly. And in another, maybe from their search history, it just says they searches for trail runners.
Okay, completely different words.
Totally different words. But semantically, conceptually, they mean pretty much the same thing. A traditional system, looking for exact matches, it would see those as two totally separate interests, maybe even two different people.
Yeah, no chance of linking those automatically. You need someone to manually figure it out, which is just impossible at scale.
It's a nightmare. So the goal, the real objective, is to identify that connection, whether it's a duplicate customer or just related information, even with these variations in names or descriptions.
And why is that so critical?
Well, think about the payoff. A complete customer 360 view, finally, unifying all the support tickets so the agent actually knows the history.
Okay, that's huge for service.
Huge. And personalization, that actually works because you understand the whole customer, not just scattered bits. It's fundamental, really. Without it, you're flying blind on some level.
All right, so let's get into the hybrid solution itself. How does it actually bridge that gap? You mentioned starting with the legacy strength, Soundex.
Yeah, Soundex. It's a classic for a reason. It's a phonetic algorithm. Basically, it codes names based on how they sound in English.
So John and John would likely get the same code, or very similar.
Exactly. It ignores vowels mostly and groups consonants that sound alike. So minor spelling differences often disappear. In SQL, you've got functions like Soundex,
Okay.
or even better for comparison, difference. That function compares the Soundex codes of two strings and gives you a score, usually from 0 to 4.
So like difference A dot name, B name.
Precisely. And if that score is, say, 4, it means you've got a really strong phonetic match. It's a great first pass for finding potential name duplicates quickly.
Got it. Simple, efficient for soundalikes. But that doesn't help with the trail runners versus outdoor running shoes problem, does it?
Not at all. And that's where the other half of the hybrid comes in. The modern power, LLM-powered vector embeddings.
Okay, LLMs, large language models. How do they fit in?
So this is really cool. LLMs can take a piece of text, like those customer notes or descriptions, and turn it into a list of numbers. A fixed-length list called a vector, or an embedding.
Numbers, how does that help?
Because the way the LLM generates these numbers captures the semantic meaning of the text. It understands the concepts.
Okay. So it's not just counting words.
Not at all. It understands that outdoor running shoes and trail runners, even though they use different words, are very close in meaning. Their vectors will be mathematically close in this high-dimensional space.
That's the key, semantic similarity.
Exactly. You can use various LLMs for this models from OpenAI, Hugging Face, or increasingly Snowflake's own built-in Cortex LLM functions, which is super convenient.
Right, keeping it in Snowflake.
Yeah, and these vectors, these lists of numbers, they get stored directly in Snowflake using the vector data type. It's basically an array of floating point numbers.
How many numbers are we talking about?
It varies depending on the model. For example, OpenAI's popular text embedding ADA002 model creates vectors with 1,536 dimensions. So 1,536 numbers represent that piece of text.
Wow. Okay. And how do you compare these vectors to see if they're similar?
You use mathematical distance functions. A common one is cosine distance, calculated with something like vector cosine a distance. The important thing here is that a smaller distance means higher semantic similarity. They're closer in meaning.
Okay, so Soundex for the names, vector embeddings for the descriptions and context. How do you actually put them together in practice, like in the Snowflake table?
Good question. You typically set up a base table, let's call it customer support match data. This table holds the raw stuff, customer IDs, names, the descriptive notes, maybe support ticket details.
And the embeddings you generated.
And the embeddings, exactly. You'd have a column of type vector to store the embedding for each customer's descriptive text.
Okay, so the data is all in one place. Now the query, how does the hybrid logic work?
So you write a query that looks for potential matches between pairs of records, let's say A and B. The condition would be something like this. Find pairs where the difference, A.name, B name, is high, maybe 3 or more.
Meaning a good phonetic match.
Right. Or, and this is the key, or where the vector cosine distance, A.embedding, B embedding, is very low, say less than 0.15.
Meaning high semantic similarity, so it catches either type of match.
Exactly, it catches both.
Oh.
So going back to John Smith and John Smith, maybe they get a different score of 4. Great phonetic match.
Okay.
And maybe their descriptions, when embedded, have a cosine distance of like 0.09. Which is really low, very similar.
So you get hits on both conditions potentially.
You could, yeah. Or maybe just one. If the names are totally different but the descriptions are semantically identical, the vector distance catches it. If the descriptions are vague but the names sound the same, Soundex catches it. Getting a hit on both gives you super high confidence.
That makes a lot of sense. It's like having 2 different nets to catch the same fish.
That's a good way to put it. It covers more bases.
And you mentioned earlier that doing this all within Snowflake is a big deal. Why is that so important for organizations? Governance, performance.
Absolutely. Running it natively in Snowflake is huge. First, governance. You're not shipping potentially sensitive customer data outside your secure Snowflake environment to some external API for embedding. That's a massive win for security and compliance.
Okay, data stays put. That avoids a lot of headaches.
A ton of headaches. Then, performance. Generating embeddings using, say, Snowflake Cortex functions directly in your SQL query can be much faster and more efficient than setting up external Python jobs, managing dependencies, handling API calls, and moving data back and forth.
Less complex architecture too, I imagine.
Way less complex. And finally, scalability. Snowflake is built to scale compute and storage independently. So as your data grows or as you need to run matching more frequently, the platform can handle it without falling over. Trying to scale external processes can get messy and expensive fast.
So Cortex is the key there for the in-Snowflake embedding generation.
It's a major enabler, yes. Functions like snowflake.cortex.embedText let you just pass in your text column and get the vector back right in the query. It dramatically simplifies the workflow.
You just insert your data, like our John Smith example, into that customer support match data table, run the embed function perhaps during insert or as an update, and then run the hybrid matching query.
Pretty much, yeah. You load the raw data, generate the embeddings using Cortex, store them, and then query for matches using both difference and vector cosine distance, all within Snowflake SQL.
Okay, that sounds powerful. But with AI and LLMs, especially processing customer data, getting the match is one thing. What about trust and reliability? Governance must be more than just keeping data inside, right?
Oh, absolutely critical. This isn't just fire and forget AI. Governance is paramount.
So what does that look like in practice?
Well, first, metadata is key. When you generate those vector embeddings, you must store information alongside them. Like, when was this embedding created? Which specific model and version was used?
For traceability.
Exactly, for traceability, reproducibility, auditability. If someone asks, why were these 2 records matched 6 months ago? You need to be able to point to the exact model version and parameters used. Things change, models get updated.
Makes sense. What else?
Then you leverage Snowflake's built-in features. Tags, for instance. You can tag columns containing personally identifiable information with, say, ISPII.
Yeah.
You can tag the match results themselves with a match confidence score or status. This helps massively with data classification, tracking quality, and enforcing policies automatically.
Policies
Like access policies, you absolutely need things like masking policies on sensitive columns, the customer's name, maybe their raw notes. So analysts running queries might see that a match exists, but they won't see the sensitive underlying data unless they have specific permissions.
They're protecting privacy.
Crucial. And finally, audit logging. Snowflake's access history tracks who accessed what data, including the results of these matching queries. You need that audit trail for accountability and compliance. It's about building a system that's transparent and trustworthy, not just clever.
That's comprehensive.
Yeah.
It feels like building a responsible AI system, not just a functional one.
That's the goal.
So this isn't static then. You build it, but then you mentioned follow-up enhancements. It sounds like it needs ongoing care and feeding.
Definitely. It's not a one-time setup. A really valuable enhancement is using something like Streamlit, which integrates nicely with Snowflake, to build simple dashboards.
For what purpose?
For analyst review, the system might flag potential matches, especially those maybe in a gray area of confidence, and analysts can look at them in a Streamlit app and quickly label them, yes, this is a true match, or no, this is a false positive.
Creating a feedback loop.
Exactly. That feedback is gold. You can use it to refine your thresholds. Maybe that different score should be 3.5 instead of 3, or the vector distance threshold needs adjusting. It helps the system learn and get more accurate over time.
Continuous improvement.
Right. And, of course, you need to run this regularly. You'd schedule batch runs, maybe daily, weekly, monthly, depending on how fast your data changes, to catch new potential duplicates or update existing matches as new information comes in.
And how do you know if it's actually working well? What are the success metrics you track?
You need clear metrics. You'd aim for high match precision, meaning when the system says it's a match, it really is a match. You want that ideally above 90%.
Okay. Minimize the false positives.
Precisely. Which leads to the next metric. False positive rate. You want that as low as possible, ideally under 5%. And of course, runtime. For a decent volume, say 100,000 records, you'd want the matching process to complete quickly, maybe in under a minute, so it's operationally feasible.
And anything else?
One crucial thing, especially with embeddings, monitor for model drift. Language evolves, the way customers describe things changes. The LLM embedding model might start performing differently over time, so you need to periodically reevaluate its performance, maybe monthly, to ensure the semantic matching is still accurate.
That makes sense. The world changes, the model's understanding needs to keep pace.
Exactly.
So, wrapping this part up, what we've described is basically a really smart matching engine. It's fast because it runs in Snowflake. It's explainable because you have the Soundex and vector scores plus metadata, and it's governed through tags, policies, and logging.
That's a good summary.
And it elegantly combines that old-school, reliable Soundex for phonetic matching with the really sophisticated semantic understanding from LLMs and vectors.
Yeah, it's that synergy that makes it powerful. You get the best of both worlds, addressing both the simple typos and the complex conceptual similarities.
And while we've talked mostly about customer data, this isn't just limited to that, is it?
Oh, not at all. Think broader. Unifying support tickets is a huge one. Imagine a customer contacts you via chat, then email, then phone. This system could potentially link all those interactions, even if they used slightly different emails or described the issue differently each time.
Giving the support agent the full picture instantly.
Huge efficiency gain, better customer experience, or think about product catalogs or internal knowledge bases, or even linking research papers based on semantic content. Any place you have entities with slightly fuzzy identifiers or rich textual descriptions, this hybrid approach could be incredibly valuable.
It really opens up possibilities for creating a more connected, intelligent enterprise using the data you already have but couldn't properly link before.
That's the potential, yeah. Breaking down those data silos in a much more meaningful way.
So, final thought for everyone listening. Take a moment and really consider the implications. What if you could truly understand every interaction, every mention related to your customers or your products or your internal processes, no matter where that data lives or how it's phrased? How might that level of precision, that holistic view, actually transform how you make decisions, how efficient you are, and ultimately how you deliver value and satisfaction in your own specific context?